All right. In this video, we're going to start to process some of our planetary data. And in this first video, we're going to do that using the percentile color combination technique. The percentile color combination technique is quick and easy to use because it makes a simplifying assumption. It assumes that the brightest thing in the image is white, and it makes all the other colors relative to that. So if the brightest thing in the image really is white, you've achieved natural color. But if it isn't, you haven't. You'll still get colors, they just won't be natural colors. If you want to guarantee natural colors, you use something called the photometric color calibration technique. And we'll tackle that in a later video. Okay. Now, for the percentile color combination technique, you can do that with any of the planets. And in this video, we're going to do it with Jupiter. Jupiter is one of the angularly larger planets. There's a lot of good detail on its surface. There's the red spot, if you happen to get it in your image. So it's a fun one to do. Okay. So I've collected already 10 red images taken through the H-alpha filter, 10 green images taken through the O3 filter, and 10 blue images taken through the U filter. And I collected these all from Cerro Tololo Inter-American Observatory, CTIO. It's our best site with the least atmospheric blurring. Planets are really, really small. And so atmospheric blurring can really affect the image. And so you want to take these from the best site possible. What we're looking at right now is the first red image. And at first, it doesn't look all that great. Jupiter is this big blur. It's in there. We did not saturate. We did not observe too long and fill up our sensor, fill up the detector. It's in there. It's just how we have the display settings set, the brightness and contrast settings. It's washing it out. What we're looking at here is mostly sky glow. Light from very bright Jupiter rattles around the atmosphere on its way down, creating a big blur. We'll fix that in just a moment. If we look off on the side, we see 2 of the Galilean moons, and then here are the other 2 right there. Okay. Well, first go to display settings, make sure you're in linear stretch mode, and just click on bright target. That's good enough for now. And so this changed the brightness and contrast. We can't see the moons anymore, but we see detail on the planet. Zoom in and put it at the center. Now frame up on it. Now we're going to need to do this in every image, and that would be a lot of work having to manually do this in every image. So here's a shortcut. Over here on the left, go to the tab with the gear on it. Turn on Sync Orientations and switch to Pixel. The options are Sky and Pixel. If you have background stars in your image, enough of them, we can put a coordinate system, a sky coordinate system on your image, in which case you want to be in sky. But these planets are too bright. We don't have enough background stars, or maybe even any background stars. And so we're going to just be in pixel coordinates. And then sync display settings. So the first thing will sync the orientation and the framing, and the second setting will sync the brightness and contrast settings. So now if I go back here and click on the next image, it loads in with the exact same framing, pixel by pixel, and the same brightness and contrast settings. And you can hop through them using the Shift arrow key. You may want to load them all in advance or not, up to you. You see, as once you load them in, you can scroll through them like a movie. See that bouncing around? That's due to the atmosphere and also the mount. It's the level of accuracy to which it can point from image to image. Okay. Now, normally when we start processing images, we do cosmetic cleaning here, but we're not going to do that with the planets. The planets are too small, and the cosmetic cleaning algorithm is not really fine-tuned for them. If you run it on the planets, it can actually screw up your planetary images. Now, if we're not using cosmetic cleaning, that means the bad pixels are still going to be in there, but we'll get rid of them a different way a little bit later. So we move on to aligning. With the moon, we used feature-based aligning, but the planets are too small for that. They have features, we can see them, but they're too small. It's not enough for the algorithms to latch onto. Now, if we had background stars, we could align using them, but we don't. So what we're going to do is we're going to do something called sources manual. We're going to go through each of these images. We're going to leave the aligner screen. We'll come back to it. We're going to go through each of these images and click on the center. Find the absolute center of the planet, and then we're going to use all those centroids to do our aligning. Okay, so we'll come back here. Let's go up to the Sources tab, the one with the star. Now, the first thing you want to do is turn Include Sources on and make sure there's nothing here, no previous work. If there is, delete it. Then turn that off. Once you do many planets, you go from planet to planet, you're going to have a bunch of stuff there from the last planet. You want to clear it out. Then make sure these three are on. Source markers. When I click on it, I want it to leave a marker. Centroiding clicks. This way, I don't have to find the center perfectly. I just have to get close. And then this algorithm will find the center for me. And planetary centering, planetary centroiding. The algorithm differs for an extended planet than it does for a star. So we're centering on planets. You want to make sure all three of those are clicked. And I'll click, I won't click, you try to click near the center. I'll click a little bit offset just to show you. I clicked over here, but it found the true center. Then shift arrow to the next one, and you do it for all 30 of them. Now, if you're doing Saturn or Uranus, we actually collected 90 images. So that's a bit of a haul. 30 is not so bad. I refer to this as the most boring video game you'll ever play. Once you get into the ones that haven't loaded, you got to give them a second to load. Just double checking. You don't want to click twice. You don't want to get 2 clicks in the same image because it won't know which one to center to. Maybe I'll demonstrate that when I get here to the end. Okay, and now we're into the blue ones. You may have noticed the red ones, we didn't see the red spot. But once we get to the green one, it gets a little dark. And the blue one, it gets a little dark. The red spot's not any brighter than anything else on the surface. It's just missing green light and blue light. And that's why it looks red. So now that we're looking at the bluer frames, we see that missing light. We see the spot. Okay, I'm going to hop through these and make sure I have 1 click in each. Okay, now, just to kind of demonstrate a common failure mode, I clicked twice here. I have 2 in this one. Let's say I did that by mistake. Okay. Now, what you do, include sources from other files, select all the sources, and then you would merge. That's this first button. It should turn blue, but it didn't turn blue because I double-clicked in one of the images. It was the last image. If I go to the last image, hide the sources, I see I have 2 of them here. So I'm going to clear those out, and I'm going to click again. Okay. Now, if I include in all, the merge button is there. Be sure to select all. All of them are selected, and I'm going to merge. The reason is images are not aligned or registered, and the label, call it anything you want. I'm going to call it Jupiter. I'm going to merge the sources. So now all the sources are called Jupiter. All those centroids, Afterglow knows they are all the same thing. These are all the same object, the center of Jupiter. And so we can use that information to align. So let's go back to the Aligner tab. I'm going to select all my images. I'm going to get out of mosaic mode. This is not a mosaic. This is stacking for depth. We need to specify a reference image, the image that the others will align to. And you can just select any of them. I selected the first in the list. You want crop to be on. We're going to crop to the overlap region between all these images. And it doesn't matter if these are enabled or not. We only have one point that we're aligning to, so all I can do is shift those points together. If you have 2 points, you could do rotations. If you have 3, you could do rotations and scales, et cetera, et cetera. But we only have 1 point, so it doesn't matter if these are turned on or off. Mode is sources manual. You can leave all this the same, and you come down here and you pick your source, Jupiter. I'm going to line everything using this merged source. Click off the box and submit. If you try to submit while the box is open, it won't take, it just closes the box. It's another error people make, and then they sit there wondering why it's not submitting. So make sure the box is closed, submit. This doesn't take too long to execute. Done. Okay, they're all centered. And we should check that it did a good job. If there are any it did a poor job for, we can just not include them in the stack. And so it reloaded the last one, and I'm going to load them all back in again. Since they've all been aligned, they're all different. So they all need to be reloaded. These are the red ones. Now, I'm going to run through them, see how it's staying put. They've all been aligned. You see little wiggles and wobbles, that's atmospheric turbulence. Okay, so those all look good. So I'm going to go to stacking. Okay, now we stack the red, the green, and the blue separately. So I'm going to use the filter over here. I'm going to type _H alpha _. So that's part of the name. That gets rid of all the other ones. I'm going to select them all. And I already have these things on. So what you want to do here, remember those bad pixels that we weren't able to get rid of? They're down there in the image. They really stand out if you do fainter planets like Uranus and Neptune. Anyway, to get rid of them, we can compare image to image to image. Since we've aligned the images, the hot pixels got moved around. They're no longer on top of each other. And so we can compare between the images and saying, hey, there's something at this pixel in this image that's not at this pixel in the other images. Let's remove it. So put rejection on Chauvenet, set low to 1 and high to 1. That essentially turns it on. Make sure your equalizations are off. That was only for mosaics. And turn propagate mask on. When we aligned, we cropped to the overlap region, and this will maintain that cropping. Okay, I'm going to submit it. Take a moment to do the rejection. If you're doing no rejection, this should be like instantaneous. Oh, but even so, it was really fast. So now I'll come over here, _03 _, select them all, submit. goes. It's done. Underscore U underscore. You really have to have those underscores because there's a U in the word reduced. For example, if I only filter on U, it gives me all the images. But here by doing underscore U underscore gives me the ones I want. Okay, that's done. So it created 3 images with the word stack in it. If you had an internet disruption, it didn't come back with the word stack in it, came back with the word file in it. So filter on stack if you need to, filter on the word file and find them. This is our combined red. This is our combined green. This is our combined blue. So let's select them all, group them, group. Just made a group and the group does not have the word stack in it. So I'm gonna get rid of the filter and go find the group. Here it is, right here. So here's the grouped image. And the 3 sub images, let's color the H alpha one red. The O3 one, let's color it green. The U-band one, let's color it blue. Okay, there we go. That's pretty good start. We can play with this a little bit. Let's go to display settings. Now, if you're looking at just the planet, not worried about the moons, right? We can't even see the moons with these display settings. Linear is a good mode. Oh, but first, we have to do the percentile linking. Again, we can look at the display settings for the red layer, the green layer, the blue layer, but we don't want to have to change the display settings 3 times. So pick one, doesn't really matter for percentile. Color composite, link all layers percentile. Now the other 2 are tied to, in this case, the red one. Okay, so stretch mode linear and saturation level. It's really high, 99.999%. I often just, for these, I up it to 100%. So basically, the brightest pixel, the absolute brightest pixel in the image is white. That'd be one of these pixels. I put the 99.999 back there, take out one of the 9s. You see, it started to wash out a little bit. Take out another 9, start to wash out. With 99.9 set for the saturation level, that means 1/10 of 1% of the pixels in the image, the brightest 1/10 of a percent, are being set to white. But that brightest 1/10 of a percent are all sitting on Jupiter. And so I normally just set the saturation level to 100%. Okay. Make sure I'm not saturating any of this. And that's great. That's a great image of the planet right there. Let's tweak this a little bit. Let's see if we can see the moons. The moons, you can try different modes. I'm going to use the midtone mode. Select it. Then you want to hit the default preset to get basic values in there. There are the moons there. Let's see here. We now have background, midtone, and saturation. And the goal is not to get detail on the planet. So I'm not going to worry about whether the planet's saturated or not. By increasing the midtone level, like we did with the moon, we can make things dark. So there's 99.999%. And I'm going to start taking off 9s. It's 99%, maybe 99.5. Be back it down, 99.25. I want to see the moons really well. You can see the color. See how that one's yellower than that one? This is Io. It's a volcanic moon. It has like sulfur deposits and all sorts of stuff all over it, coloring it yellow. This is Europa. It's an ice moon. So it looks whiter. It's covered in ice. Ganymede, Callisto are also colored in ice, and so they should have a whitish tint to them. Anyway, once you're happy, you should save it to your workspace. All right. And once you save it, you can export it at full resolution right here. And a fun thing to do, once you can see your moons, is to compare it to Stellarium. So I'm going to open Stellarium, show you how to do that. Okay. Function F11 to minimize it. And we don't really need to set the location for this one. You do want to put the time in universal time. Here we go. And let's hide the ground and the atmosphere. We're going to search on Jupiter. There it is, and zoom in. And by clicking on the button here with the telescope, puts it in the same orientation as our camera, maybe a flip or a rotation, but approximately the same orientation. Let's go back to Afterglow just for a second. Click on any one of the layers and come up to the File Info tab, the second tab. And it gives us the date and time. So I'm going to come over here. And this particular image was taken January 19th, 2:46, something like that. And so we can see Io, Europa, and over there, Callisto and Ganymede. Let's take this image here. And I think I need to flip it that way. Yep, that looks right. Gonna frame it up. And for this one, I really wouldn't mess with the color settings. You know, the colors are what they are, and I think they're sufficient. You can really see that this one is yellower than the one next to it. And indeed, that's Io, which is supposed to be yellower than Europa. So that's a fun thing. You can identify the moons. You can check out the colors of the moons. Okay, it's ready for social media. All right, that's it for this video.